Swayam Prabha. Digital India. Educated India.
Hello everyone. Now in this module we will start with the methods of performance evaluation of projectile impact on particularly on the bulletproof clothing. So, the different techniques of ballistic performance evaluations are: one is dynamic impact test. So, that without any bullet firing we can do the dynamic impact test to assess the performance of the ballistic protective material. Next is the weapon test. Weapon test is basically it is done to measure the residual velocity that we can do, and third one is NIJ standard, where actual fire will be there as per the strictly as per the standard, where the type of bullets are specified, type of the distance is specified, the speed is specified. So, everything as per the standard that we have already discussed previously also in detail, but here we will see the how to test. And fourth one is that V50 measurement, that is the velocity where the probability of penetration is 50%. So, these four different types of performance evaluations are there, and fifth one is that after the test the that back face signature to actually it is for trauma on the wearer. So, back face trauma it is also called. So, that also we can test by measuring the thickness of the backing material of depression of the backing material, that also we have discussed earlier. So, dynamic impact test is done in the laboratory. So, here in the laboratory it was dynamic impact test was used. Now, this is the setup here. So, this is the movable assembly where the impactor is there, which will be guided for a particular point, and here this is the fabric specimen, fabric and clamping plate. So, fabric clamping plate is there, and this is the schematic of the dynamic impact test instrument, where the fabric is kept here, maybe any protective bulletproof fabric. This is the striker here, this is the striker here, and striker diameter is 13 millimeter, that is standard diameter is 13 millimeter diameter, and the inner jaw diameter, the whatever this is actually the grip is there, that inner jaw, that diameter is 76 millimeter, and outer jaw diameter is 108 millimeter. So, that is clamped, fabric is clamped, then the striker will strike at the center, and total fabric size is 160 millimeter its width and by 160 millimeter. This is the photograph of the test setup. Next is the weapon test setup. This is as per the standard here. So, this is the weapon mount, here muzzle is there, and here is the test specimen. We keep the distance as per the standard 11.8 meter. Here two screens are there, that is the to measure the speed of this bullet, and also after this penetration we have two more screens, screen 3, screen 4 at different distance. 4 optical screens are used to measure the bullet velocity. So, these optical screens are there before and after the impact. So, how much the velocity is actually reduced, that it will measure, and it will measure the energy absorbed by the test specimen, that is the. But here in weapon test, the requirement is that this bullet should penetrate through the test specimen, so that we can measure the energy absorption. So, here is that the different screens are there, and which will measure the speed of the bullet. Now, here this is the impact test. Impact test, as per the standard, the distance of the sensors are kept. So, we can calculate the velocity of the bullet, and there is a target, the specimen is there, and below the behind the this specimen there is a clay, that is a backing material is kept to measure this back face signature, and there will be a protective wall. This is impact testing is there, and impact velocity we can calculate using this formula. You have a V2 minus 1.5 multiplied by V1 minus V2. So, with this, so impact velocity we can calculate here. Now, to calculate the energy absorption, so what the energy absorption by the fabric can be calculated using the impact velocity and the residual velocity after impact. So, the here suppose there is a, now like let me draw in the, this is the fabric and there is a bullet impact. So, at impact velocity it is a V1 V1, and after impact it is penetration, it is going out. So, at the speed of V2. So, from this speed difference, if we know the mass of the bullet, we can calculate the impact energy. Now, we can see here, these are the actually chronographs, where the using the photo detection we can calculate the speed of the bullet here, if we know the distance, and it will measure the time difference, and from there we can calculate the speed. So, this is the bullet which moves at certain speed. Here the speed V 1 is calculated by chronograph 1, and after penetration, the chronograph 2 will measure the speed of the bullet. So, that is V 2, and this difference in speed is due to the energy absorption. So, energy absorption by the material will be half m V 1 square minus V residual V r square. So, this is V r. So, V initial impact velocity and residual velocity V I square minus V r square. So, from there we can calculate the energy absorption, but here in this test our idea is that the speed should be such that it penetrates through this material. If it does not penetrate, so this energy absorption method will not be valid. E is the energy absorbed, m is the projectile mass, V 1 is the impact velocity, and V r is the residual velocity. So, by using this method we can calculate the energy absorbed by the material. This is also one area of one way of expressing this ballistic protective, evaluating the ballistic protective characteristics. Then next is the NIJ standard that we have discussed earlier also. So, baseline ballistic limit in that standard. So, that is V 90 performed on one armor. So, V 90 V 50 sorry V 50 we have to make test. So, NIJ 10104 standard, where baseline ballistic limit is calculated V 50, that is here no pass fail criteria is there. Here we have to calculate the V 50, that is the velocity at which the penetration probability is 50%. That is the level, that is the limit we can calculate, that is the performance of our material, ballistic material. So, that is called baseline limit test. Here we cannot say this is the pass or fail, we cannot have this pass fail criteria, and it is designed to statistically measure the penetration performance. So, penetration performance is statistically measured by varying the speed of the bullet. So, here a minimum of 12 shots per panel for type 1 and type 3A we have to perform with the lower level of protection, here including at least 5 perforation, 5 partial perforation and 5 complete penetration. So, 5 partial penetration will be there and 5 complete penetration should be there out of these 12 shots. For high protection, because there penetration is not studied, for high protection like 3 or 4 level, penetration is not studied, there backface signature is studied or different other characteristics will be studied, but here we want to know the baseline ballistic limit. then arithmetic means of 10 velocities, 5 for complete penetration and 5 for partial penetration is calculated as the panel's baseline ballistic limit. So, first we are testing the, that is the baseline ballistic limit we are calculating, and these are tested in dry condition. So, clay backing material is there and shots are fired from the fixed distance to the target, and here 5 meter for type 1, 2, 3 and 3A, that is the 5 meter here we keep, and for type 1 to type 3A 9 millimeter round nose bullets are used. So, round nose bullets are used here. Now, how to calculate the baseline ballistic limit like V90. So, here you can see the velocity for which the probability of the perforation becomes 0.5, that is the term as the V50. Now, we can see here. So, we have calculated the mean velocity, we have calculated the partial penetration and complete penetration. From there we can plot this curve. So, at different velocity we are plotting here. So, we can see this is the probability here, probability where probability is 0, that is V, this V 0. Now, we are increasing the speed, increasing the speed here, velocity, and as we increase the velocity based on our the probability distribution, we can calculate the probability of penetration. So, we have got the value, average value, from there we can calculate the probability of penetration. So, gradually we are increasing. So, at certain velocity above that, so below certain velocity there is no perforation. So, I will go back here. So, at least 5 partial perforation will be there and 5 complete perforation. We know these speeds. So, here there will be no perforation, but within this there will be partial perforation will be there. So, that we can calculate the probability of perforation here, and above certain speed, say V 100, where there will be 100% perforation, complete perforation. So, from that we can plot this curve, and where the speed, the probability is 0.5, that is the 0.5 where the line crosses this line, intersect. So, that will be termed as V50. From this plot we can tell that V0 means probability of penetration at this speed will be 0, and V100 means probability of penetration at this speed, at this velocity will be 100% probability, and V50 will be the 50% chances are there, it will get penetrated on 50%, there may not be penetration. So, probability of perforation is 0.5, that is the ballistic limit is here, okay, baseline ballistic limit. So, positions of the shot for V50 calculation, there it cannot be actually there should be some specific position. Now, we can see as per the NIJ standard, these are the positions. So, here they cannot be shot all at the center zone. So, it will be distributed. Next is the backface signature test, that we have already discussed in detail what are this backface signature. Now, it is tested. So, backface signature is measured by the clay, backing clay, and it is a measure of the blunt trauma experienced due to the non-perforating bullet. So, bullet is not perforating, but still the wearer feels the trauma, that blunt trauma, that it measures the blunt trauma. This is a critical aspect of ballistic evaluation, as it determines the internal injury to the vital organ during the ballistic impact. So, that is very important. So, although the bullet is not penetrating, but still there may be some internal injury. So, that test has to be there. This is obtained by measuring the maximum depth of deformation at the backing material of the armor panel, that is the armor back of the armor panel, there will be backing material will be there. So, this is actually done by the non-perforating bullets on the backing material. So, if the bullet penetrates easily, so suppose this is the backing material, so there will not be any backface trauma. So, it will be simply penetrate it will, but if non-perforating bullet is there, so there will be depression. So, it will bend, and that due to the energy it will absorb. So, then at the back side there will be this deflection, this depression will be measured. So, this is this analysis should be done as per the NIJ standard. NIJ standard is clearly it is specified. So, sample sizes for different projectiles, you can see these are the sample size. Here 5.56 millimeter FSP, the sample specimen size is 380 millimeter by 380 millimeter, and here the difference should be minimum 100 millimeter, okay. And for 0.44 magnum, here there will be different distance specifications are there. So, as per this specification, at different distance it has to be maintained. So, instrumented drop weight impactor, this is the drop weight impactor. Piezoelectric accelerometer, where and charge amplifier, ring magnet. So, as soon as it is released, this impactor will free fall, will have free fall on the specimen, and we measure the energy. So, for high speed photography, the instrumental system is there here. So, for there is a mirror, so we can the direction of projectile is there and this is the target. We can measure the with the high speed camera we can measure the this projectile path. Now, let us discuss the deformation of body armor during impact. So, there the body armor, that is hard body armor or soft body armor, they have different types of impact. First, let us see the hard body armor, how they get deformed. So, as we have already discussed earlier that they will crack first and spall will generated. So, this is the type of strike here, and here that you will see that this spall will generate here and they will form crack, and this is the spall liner. So, which will restrict the spall. So, we can measure the characteristics of the spall generated. In the first stage, this is the ceramic material and we have the base. At first stage, we will see this fragmentation will be there and they will actually try to move at fast speed in the different direction and crack formation will be there. In the second stage, you will see that the base. So, in first stage you see there is no such deformation here in the base, but it is striking. In the second stage, the base gets deformed due to this high pressure here and crack formation. So, how to calculate the deflection produced by impact? So, this is the deflection here. If we see here, this is the impactor, it is coming from the height h, it is falling. Okay. Here this is the specimen here. P is the force applied on the for deflection. This is the for deflection we are applying the force P, and this sigma, this is the delta, this delta is the basic depression is there. This delta is the, so E is the Young's modulus. Here Young's modulus is E of the material, I is the moment of inertia. So, work done here by applying the force P. So, P is P we can calculate, L is the this total distance between the two support. So, this is the force and total work done by the force will be, this is the work done. If we know the area of this, we can calculate this zone. So, then it will be the work done by applied force, which is equal to P delta by 2. So, this is the delta and P delta, P is the force and D delta is the deflection. If we use the half of that, so because that will be, it is not totally deforming. So, P delta by 2 and there P if we replace. So, with the P is here 48 EI by LQ, that is the standard formula here, and from there we get this relationship. So, here the work done by the applied force P is equal to delta square, delta is the deflection, maximum deflection, 24 E I by LQ. Here the H value, it denotes as before the distance fallen by the impactor. It is basically before the impact. So, this is the total distance travelled by the impactor, and the equation for determining the deflection delta is becoming this one, because here P was the, just I will go back, this is the P value force. Okay. Now, you can see W H plus delta, that is the total energy. Total energy is this one. This is the work done, total work done by the applied force. So, here is the total work done by the applied force is WHG, so which is equal to delta square 24 EI by LQ, which was earlier derived. Weight of impactor W, H is the distance of the fallen before the impact, distance fallen before the impact. Now, let us see the deformation of soft body armor during impact. Now, with a different time level, so we can see the deformation. So, this is the say top view, this is side view. At first, at certain time initial when it is impacting, there will be certain depression at the impacting point, which is at 0.05 millisecond. After the 0.05 millisecond, the photograph is taken. The next is that after 0.1 millisecond, there is certain depression, more depression, and we see the lateral wave is becoming more, and it is taking the more and more material is coming into picture for the energy absorption. So, this total zone has increased. Initially it was very small, within a smaller range, but with the time as it is flexible. So, the more and more material is coming into picture. And third 0.15 millisecond, the depression it is taking, it is penetrating through the structure, and at 0.2 millisecond, this layer is not able to prevent this, and there is a damage has taken place. Although sufficient energy has been absorbed, but still it is actually. So, at 0.15 second, the other side has started breaking, So, here at 0.2 second it is broken and it has penetrated, and 0.25 millisecond it has damaged and the projectile penetrated through the this material, and these are the different stages of during the impact stages of soft body armor. Now, if we know, if we understand this mechanism, we can create the structure, so that the energy absorption will be more than that, it can absorb more energy, so that this bullet can be stopped, that projectile can be stopped before it penetrates. Now, we can see that multiple system. So, we impact response of a multiply system. So, one is broken. So, if we use multiple layer, so you can see here this is type of system we can generate here. So, here if we see this is a single layer has been damaged, but if we see the multiple layer, so gradually the energy will get absorbed. Now, fabric deflection during impact, this is the fabric deflection that we have already discussed in detail, that is the longitudinal wave will get generated and fabric will get deflected. Main deflection will be on the projectile side where the force is there. Now, if the load breaking load of the fiber is low, then there will be damage and projectile will freely penetrate. So, the wave will get generated due to the impact. So, as a bulletproof vest is not a solid, this whatever we, it is not solid material. So, bulletproof vest is made of mainly textile material, and the bullet will not stop immediately, instantly it will not stop. So, it will, that bulletproof vest will get deformed and the bullet will travel through the vest, and but it is not actually penetrating completely. So, it will travel through the vest, it may damage few layers, but in between it will be stopped, it will be caught within the structure. But in hard body armor, that bullet should be, so it will be stopped at the first instant. This means the wearer will still feel the impact of the bullet on their body, and while the blunt force trauma of the bullet will undoubtedly be painful, it should not be life threatening. So, the blunt trauma, the back face signature should not be very high. So, bullet is not penetrating, but still it may be painful, but it should not be life threatening. Now, body armors are available at different size, and the sizing is very important, because the performance is related with the size of the body armor. So, body armor comes in a full range of size from small to double XL. The larger the size, the wider the protective panels of the bulletproof vest. So, for larger size definitely there will be the body size will be larger. So, panel size will be larger and weight will also be definitely high. Now, these are the different size chart where the height, chest are mentioned here and also sleeves. So, height measurements are only a guide, all measurements are in inches. So, you can see here different types of sizes, small, medium, large, XL, double XL. Depending on the wearer, we can use different types of body armor. So, body armors should be maintained properly to keep its performance intact. So, cleaning should be done as per the standard. The body armor should be cleaned straight after the wearing using a weak liquid detergent and warm water. So, that we should maintain this, otherwise there will be bacterial impact on that which may damage the fiber and the performance may be deteriorated. So, after use immediately it should be cleaned with a weak liquid detergent and warm water. So, strong detergent we should not use. Sponge the vest cover, do not immerse the vest in water as it could damage the panels. So, we should use the weak liquid detergent and we should sponge the vest. We should not immerse into water like normal cloth cleaning, and we should not dry it in directly on the sunlight, otherwise it may damage by the UV ray. And storage, body armor should be stored in a flat when it is not in use. We should not fold it, because while folding, if we fold that at the crease point there may be some damage may take place. So, we should always use keep it in a flat position. This will stop creasing, wrinkle formation in the ballistic, and in the wrinkle formation or the crease portion there may be some damage in the fiber due to the high crease. So, that should be avoided. Washing is, we should not wash the inserts as this could cause the damage of ballistic fiber. So, the washing is not recommended, only cleaning by sponge. So, if required can be lightly sponged with warm and soapy water with light alkaline. The covers are made from various material and the washing instructions should be followed strictly, and in case of damage, so body armor should be visually inspected for damage or excessive wear before every time. Okay. So, before every time it is worn, so we should actually visually see any damage is there or not, okay, or excessive wear and tear, that we have to see carefully. And we should not wear any body armor which is actually visibly visually if we identify any damage. Now, there are instructions for inserting the protective panels in the body armor. So, bullets, stabs, spikes proof vest are designed to be worn in specific direction. So, that particular directions are given. So, we have to follow the strict directions. It is important to ensure the ballistic panel within the vest. So, is facing the correct direction at all time. So, there may be if we cannot change the direction of the panel which we are using, the correct size has to be used. So, in that face side has to be used always in the face direction. When a bullet strikes a bulletproof vest, its impact absorbed by the many layers of fabrics within 3 nanosecond time, okay, and it is caught and prevented from passing through the vest. So, that is important. So, for that the panel has to be inserted correctly. However, this method of stopping the bullet is directional, which means that it works only when the panels are facing at the correct direction. So, because we have to stop the bullet within 3 nanosecond time by the panel, but the panel has to be is designed in such a fashion, so it will stop in that direction. So, that engineering is done in that way. But if we do if we wear the panel, we insert the panel in the opposite direction, then this total function will not be performed. Okay, so, correct facing should be there. So, you can see this is insert is there. If the panel is facing the wrong way, then the wave of fibers become practically useless. So, whatever we are using the fibers, okay, that will be practically useless, leaving the wearer open for serious threats. So, that is very important. Inserting is very important. The same applies to stab and spike proof vest. So, any protection we have to, for high threat, we have to insert this panel in a right direction. If the protective panel is facing in the wrong way, it becomes easier for pointed objects to pass through, as they are not designed to protect against the threat from that direction. So, as I have told, the designing is that, so this side is the protective side. If it enters, then the next layers will come into picture. But if it is placed in opposite direction, then it will totally fail, because the design is not in that direction. All protective panels are clearly marked with the direction. So, that is clearly marked. Before inserting, we should see the instruction, okay, how it will be inserted, which will be in the top, which will be in the face. So, everything is there, and it is important that wearer ensures they are aware of this, all this at all time, because they have to ensure that they are following the instruction properly. So, if the wearers remove the vest panel in order to wash out outer carrier, so then always attention must be paid when putting the vest back together. So, that panel when you are putting, so you have to be very cautious, ensure that the panels are reinstated properly in the correct direction, facing in the correct direction. Now, we can adjust. So, most bulletproof vests are adjustable at the waist to provide the wearer well fitted and comfortable vest. So, that is some adjustments are there. Armor should not be worn too tight, as they may increase the body heat and restrict the movement. So, that should not be too tight. So, proper size has to be maintained and selected. So, they are affected by water and sweat, these body armors. So, the armor is made of aramid fiber mainly, and this will lose some strength, protective properties if they are totally immersed in water for long time. So, that we have to see, and this will only be temporary until they are dried again. So, in wet condition their properties, protective properties deteriorated, and our body armor generally is affected by rain or sweat. Now, if we see the future body armor materials, there are some future body armor materials are there. So, all these materials we can use for future body armors. Nano ceramics we can use, nanoparticle embedded fibers. So, polymer, nanoparticle and fibers. So, that composite we can make here. Then nano ceramics we can use to make the body armor material. So, there are different options available. So, fiber, composite of polymer and nanoparticles, that we can use here. So, polymer with a nanoparticle along with the fiber. So, we can make composite. So, fiber, mixture of polymer and nanoparticles in fibers. So, that also you can use here. So, in fiber we use the nanoparticle, and mixture of polymers we can use. So, mixture of polymer and nanoparticle, then fibers we can. So, fibers filled with nanopowder. So, different types of fibers we can use. So, the different fibers and Kevlar, Dyneema, okay, M5, nanofibers we can use, different types of particles, nanoparticles. So, nanotube. So, different types of nanoparticles we can use, ceramic particle, nano coated metals. So, all these options are there for future material, future armor. So, there is one approach to reduce the bulk in soft body armor. So, soft body armor we can use the multiple layer, that is true, multiple layer we can use, and we can get the required protection. Now, here the bulk is high and weight will be high. So, it will lose its flexibility, will be compromised. So, our challenge is to that can we have a soft body armor with a lower bulk, reduced bulk, okay, and reduced weight. So, that is the challenge. So, there are different approaches. So, one of the approaches is the shear thickening fluid. So, this approach, the development of resin fabric composite we can have to reduce the bulk. So, application of 3D woven fabric, application of non-woven fabric as cushion layer that we can use, and incorporation of carbon nanotube nanofiber in the fabric to enhance the strength, and application of shear thickening fluid in the fabric. So, this application of shear thickening fluid approach is nowadays getting popularity, because with the same bulk, lower bulk and lower mass, we can use the characteristics of shear thickening to enhance the protective performance. Shear thickening is that at higher shear rate, when bullet is strike, any projectile strikes the shear thickening material, due to the higher shear rate, it gets thickened, it will act as a solid. In normal case it is a liquid fluid, but in as a higher shear rate this will act as a solid, and that helps in protection. Let us see the shear thickening fluid. The shear thickening fluid is STF, it is called, are basically two phase concentrated dispersion. This two phase dispersion. One is that solid phase, which consists of nano or submicron particles, solid phase. Another is the fluid phase, liquid phase, consists of a medium or carrier fluid in which the particles are dispersed. So, it is basically dispersion model. These are the particles. Okay. One is fluid is there and these are the particles. The mechanism of shear thickening fluid is that shear thickening is a property that shows a significant increase in viscosity above the critical shear rate. That is important. Above critical shear rate, it increases the viscosity to a great extent, so that it acts as a solid material. The viscosity is so high, which transfers the shear thickening fluid into a material which is like a solid like property, and that property helps in preventing the projectile impact at high speed. Now, we can see here this is the shear rate and viscosity. If for any Newtonian fluid, that viscosity is actually changes with the speed at linearly, but non-Newtonian force velocity, that is a fluid, it may increase or may decrease with that. If it increases, if it decreases with the shear rate, then it will be calling at shear thinning. So, this is a shear thinning material. Now, you can see this is the shear thinning, when the viscosity reduces with the increase in shear rate, that type of liquid is called shear thinning liquid fluid. And in after certain velocity, critical velocity, there will be certain increase in the viscosity, and it will act as a like a solid, where this particles comes very close together, acts as a solid. So, So, STF treatment has been shown improved impact resistance of Kevlar fabric, fewer layer can be used to fabricate the body armor. So, if you can reduce the number of layer, that means you are reducing the bulk of the material. So, fewer layers can be used to have equivalent protection. So, and as we are using a lower number of less number of layers, so it will remain flexible and comfort will be there. So, transmission of moisture, vapor, air will be maintained. So, Newtonian fluid you can see. So, shear stress equal to viscosity multiplied by shear rate. Now, this is the Newtonian shear rate and shear stress. So, shear stress. So, in Newtonian viscosity remains constant, it does not change with the this shear rate, but for shear thickening fluid, with the increase in shear rate the viscosity increases, shear thickening, and shear thinning the viscosity reduces. So, this is the viscosity Newtonian fluid with the shear rate. So, the viscosity remains constant, shear thickening it increases and shear thinning it reduces with the shear rate. So, for this ballistic protective clothing we use the shear thickening fluid. So, we will stop this ballistic protective textiles, and next session we will start with another mechanical protective textile. So, we will discuss the protection from cut protection clothing. So, till then, thank you.